Good morning, everyone. Welcome to the session of the high-speed railway. Today, I'm Pirapong Tiskiam from Chiang Mai University, the moderators of this session. Okay, today we're gonna talking about the high-speed railway. I think most of the Thai people waiting for such kind of the modernizations of the transportations of the high-speed rail, or we call in short HSR, projects in Thailand. And we got the 4 panelists with me on the stage. I would like to introduce them first. The first one, Mr. Thipu Chitranukho, the Deputy Director General of the Department of Rail Transport, Thailand. The second one, Mr. Liu Junyang, CRC Corporation Limited, China. The third one, Mr. Yosuke Minami, Research Fellow, Japan Transportation and Tourism Research Institute. The last one, Mr. Jürgen Supik, Treasurer of the GTRA and CEO, Dodge Consult Asia Company Limited. Okay, first of all, I would like to lean the background of this session a bit, because everyone would know that the high-speed rail gonna be the new transportation mode of Thailand. But I think most of the Thai people know about the high-speed rail very limited. That's why today we got the expert with me on the stage, and they're gonna come to share the views of the organizations, the missions, and the roles on the high-speed rail in China, Japan, and Germany. We hope that the output of these sessions, everyone would know more in different perspective about the high-speed rail. I think, of course, to me myself, I know a little bit about the HSR as well. Okay, let me start with the Thailand situation first from Thanrong Thipu to lean the baseline, because we have no high-speed rail yet in Thailand. It's still under constructions, and Rong Thipu will come to discuss and lean some background what's going on about the high-speed rail construction projects in Thailand. Okay, let's start.
Very good morning, and thank you for joining us for this session. This morning, as you say, that we are in the process of developing the high-speed train in Thailand. We are knowing the project. I think when I first joined the Ministry of Transport, I think more than 20 years. So actually, the high-speed train is not really the fresh new one in Thailand, but we are on the process of the planning and developing the project. Until now, it is under construction and will go on. And by 3 or 4 years, we will have the operation in high-speed train. So today, let me introduce about the high-speed train, what is going on in Thailand. First, I would like to mention about the player of the railway development in Thailand. First, of course, we have the Ministry of Transport, which is the one who allocate the budget and establish the regulation and policy for the railway development. We have the Office of Transport and Traffic Policy and Planning, who is doing the master plan for the transport development. And we have the State Railway of Thailand, who is not only the operator, but they are also the infrastructure owner also. We have the Rail Technology Research and Development Agency, which is the organization for this event. They just set up last year, who is going to take care of the railway technology, research and development, human resource development. And we have the MRTA, the Mass Rapid Transit Authority, who is the owner and give a concession to private sector for running the railway in the urban area, not only for Bangkok, but also for the other urban city also. You can hear that in Chiang Mai, Phuket, and Korat, there will be the mass rapid transit running project. And the last one is ourselves, is the Department of Rail Transport. We just have been set up for 4 years. This is our 4 year for us. Our main role is to be the regulator of the railway. We don't have the regulator before this. This is just the first time that we taking care of the role of the regulator in terms of economic safety standard. And also we doing the planning for the railway sector development also. And the last role is operator that we have at this time. We have the RRTC who used to run they are running the red light train, commuter train now. And they used to be the one who operate the airport rail link between Suvarnabhumi and Payathai. This is the fastest train that we are running. It is about 160 kilometers per hour that they do. So they have the experience of running the speedy train. And we have the State Railway of Thailand who taking care of the commuter train, taking care of the long distance train, and also the local train. We have the BTS, who is the totally private owned company who taking care of the infrastructure development and also the E&M. And we have the BEM, who is also the other concessionaire, and we have 2 more monorail operator this year, the North Bangkok Monorail Company and East Bangkok Monorail, and the last one is the Asia Erawan, who is the concessionaire of the high-speed rail link between Bangkok to EEC area. And we also have a relationship with the Bangkok Metropolitan Administration or BMA, who is the local government. They are taking care of the BTS train. So this is the big picture of the railway development player in Thailand. And also we need to talk about the industry that join us, three of us today, that going to help us develop the railway in Thailand. Let me talk about the Department of Railway Transport a little bit. We have about 100 people set up for 4 years already. We have the main role for the legal affair division first, and the other one is the safety and maintenance standard division. The third major role is the strategy and planning division, and the last one is the rail transport regulation division. And let me give you what we have done for the 3 years already. This is about the 30 standard that we have been issued for the railway today, and we are going to develop the high-speed train standard, which is on the process of developing. After that, we will have the standard for the high-speed train in Thailand, and we will make sure that all the major party can use this standard. And the other one, because we don't have the license, so this year we are going to give the license to the operator. There are more than 1,000 to 12,000 railway license and regulation that we need to give the license. Maybe 7 operator, 2,000 driver that we need to issue the license, and about 10,000 train registration that we need to make, and we try to make it online. That we call it the e-license system. That all the registration can be made by online, and you can show the registration and the ID on the smartphone also. Talking about the strategy and planning, because the high-speed train is linking one point to another point, if we want to make it successful, we need to develop the other feeder system also. So in the urban area, we need to have the good MRT, the commuter train, the tram, and local train. And for the regional train, we need to have a good long-distance train and the double tracking that we are doing. And you can see that on the left-hand side is what we used to have, about 4,000 kilometers. Most of them are the single track. And we have the master plan to develop the double track. After we finish that, we will have the double track about 3,000 kilometers. And you can see that in the major corridor on the red color line that we are developing the double track train. So we have been developing it since 2018. And by the end of this year, all the major corridor, 7 line section will be complete the double track. Therefore, when we develop the high-speed train and we finish, it can be a feeder to the high-speed train that link the main station to the sub-urban station. We also have 2 new lines, which is under construction in the purple line, The first one is then Chai to Chiang Rai Chiang Khong connecting Lao PDR to the north of Thailand, and also Ban Pai Mukdahan Nakhon Phanom, which is going to connect the northeastern part of Thailand to Lao PDR and to Vietnam in the future. This is the picture that we are developing the double track train. This is can show that the section of Map Tapao, Map Kabao to Pasadet, which is the tunnel that shortcut the link between the northeastern part of Thailand and EEC area. Therefore, all the cargo exporting to the port Lam Chabang can be shortcut from 3 days to only 1 day now. So the export is going to be more efficient with the new double track and the new shortcut of the tunnel. And this is the section of the Nakhon Pathom to Chumphon part, double track train also going to link to the southern part of Thailand also, which is going to be finished very soon. And talking about the high-speed train, we just have the new Krungthep Aphivat Grand Station. This is operating at this time already, and we are on the planning of developing 4 sections of high-speed train. But of course, we need to prioritize 2 of them first. The first one is Bangkok to Nakhon Ratchasima, which is under the construction already. We work closely with the China and the Lao PDR for this section, and it hope that by the year 2028 it will be operate for this section. And for the other one is the Don Mueang to Utapao, which is linking Bangkok to EEC area. We already award the contract to the private sector, and they are on the under construction of this part. And by the 2028, the same year also, with the open of the Utapao airport, hopefully we can have these 2 high-speed rail. And the other 2 sections that we on the planning process is the Ratchasima to Nong Khai. We have prepared the detailed design and the EAA already, and hopefully we can submit the project approval with the new cabinet by this year. And the other section that we also work closely with the Japanese government, we have the feasibility study to the northern part of Thailand, Bangkok to Pittanulok and to Chiang Mai. We have done the feasibility study already and can go on for the next stage. For the high-speed rail Northeast project, and you know that from Kunming to Vientiane, Laos and China, they already operating the high-speed train already, and some of us maybe have experience of using that high-speed train. We know that even though this one is the 160 kilometer one track linking from Vientiane to Kunming, and the train might be run efficiently, good, but at the border checkpoint you need to do the CIQ, to do the custom clearance. But some of my friends tell me who has experience that during the changing at the border it takes time, maybe 1 hour. Therefore, if we want to run the train smoothly, we have to do the management and also talking about the procedure and standard of the CIQ clearance also to make the linking between these 3 countries very efficiently. And for part Bangkok to Korat, as I talked earlier, that we are under the construction. This one is 250 kilometers, and with the maximum speed of 250 kilometers per hour. And we have about the tunnel, and we have elevated structure about 200 kilometers, and it started the construction already. And this is the picture that we have been done, but the total progress of the project is about 24% due to the fact that we have the effect of the COVID-19 for the past 2 years, that some work have to stop their work. And also the other thing that there are some of the contract that cannot start the work yet due to the problem of the protest about the Ayutthaya station. They are worried about the impact of the heritage site, that we are also working closely with them. And by the end of this year, I think by the end of this month, we can start the contract for this section, so they can go on according to the plan. And this is the picture of the section of Kutchik that we award the contract to the first contractor. They have the progress about 90%, so you can see that this long elevated structure has almost complete and maybe can deliver to the ENM project. And to the second phase from Nong Khai to Vientiane section, from Korat to Nong Khai and to Vientiane, we already finished the detailed design and we almost finished the EIA process. The SRT is going to finalize the EIA. After that, we can submit this project to the new cabinet and can start the process of the bidding and construction. And by the year of 2031, we hope that this section can be finished. But actually, to link Thai, Laos, and to China, we just not only have the high-speed train, we also have the meter gauge that linking the network already. We have the network 1 meter gauge linking to Nong Khai and to Vientiane already. We also developing the new passenger station called Ban Kham Sawat, which is the new station that we just finished the construction work, and we are working with Lao PDR to train the driver to drive from the Nong Khai to the Ban Kham Sawat directly. Therefore, for the people who travel from Bangkok or to Pattaya to Ban Kham Sawat to in Vientiane can use the meter gauge train. So therefore, we can run smoothly for the first phase. For the second phase, we are developing the new bridge. That Department of Highway is developing the conceptual design. They already finished this month for the new bridge. So there will be the new bridge linking between these two sides. And we also developing the new freight terminal. There will be one in Nata Dry Port that the SRT have already finished the detailed design and the bidding document. They are submitting the bidding document for the approval for the directing board of the State Railway of Thailand before submitting to the cabinet. And after it has been approved, it will start the PPP process. So for the cargo, there will be 2 or 3 links at this one. One is the Nata Dry Port in the side of Nong Khai, and there will be the other one, the Tha Na Lang Dry Port, which is operating in Lao side, and the other one is the South Vientiane Station cargo in Vientiane. There will be 3 freight stations here. The Tha Na Lang Dry Port used for international cargo. The domestic cargo will use the South Vientiane freight station, and for the Nata Dry Port we use the international also. This is the picture of the Nata Dry Port that we have been preparing. So this section, the 1.435 and the 1 meter gauge will be the station that the cargo will be transferred in Thailand before going into Laos and to China. So you can see that there is the guaranteed train that going to transfer the cargo between these 2 gauges. And we finished the design already, as I mentioned. And this is the bridge that we finished the conceptual design. We already have 1 bridge that used for the car and the train. But during the high demand of the freight and the traffic, the bridge is going to be congested. So we are going to develop the first phase. On the right-hand side, it will be the rail bridge for 1 meter gauge, 2 track, and 2 gauge for 1.435 gauge. So there will be both standard gauge and meter gauge for this new bridge. And this is the Vientiane station that linking passenger from Thailand to Vientiane. And for the final part, I would like to mention about the thing that we learned from the high-speed train development in Thailand. We have found uncertainty during the COVID-19 a few years before this. We have the project delay in construction of the phase 1. And the phase 2 also affect with the COVID because during the EIA, we cannot send the study in the area. For the border checkpoint also, we have learned some experience that during the COVID-19, we have to close all the border with the zero COVID policy. Therefore, in the future, when we develop the high-speed train and linking the train to the 3 countries, we have to thinking about this also, how to use the technology and how to do the management that we can go through the linking if there is the problem like this. For the operation, we have to thinking about the passenger and the cargo seamless transfer. As I mentioned before, that if you want to go to the through operation, we have to talk between these three countries that how to run the train smoothly. And for the benefit sharing also, and especially the transfer fee, that we have the thing that we talk about the VLT at this time, and also the South Vientiane station, that how can we share the fee and reduce the cost of the total cost between these three countries when we transfer the cargo. For the management, we have to talk about the national single window that can make the process of the custom clearance very efficiently, and also the tracking, the IT, the tracking system. The customer want to know where the cargo is, so we want to develop this kind of thing together. For the regulation also, the CIQ and CTA, if we want to run the train smoothly, that if we have the common control area, at least to the border checkpoint, and if it would be the best if we can do the common control area for the three countries together, so the transit good can be, the transit passenger can be really efficiently. And also if we can have the seal lock, the digital lock at the cargo container, therefore the custom don't have to open the container every time that we change the country. If we have the digital lock, if we have the custom clearance good process, that will make it more efficiently. And for the standard also, because at this time, if we want to send the cargo to China, we need to have the reefer container standard. Therefore, if we make it clear for the standard and development for the container cargo, we can make this more efficiently also. For the feeder also, very important, not only the high-speed train, if we need to have the commuter train, we have the bus and TOD developed along with the station to make the high-speed train efficiently and successfully. And for the cargo, we are also going to develop the cargo train, the truck terminal, the internal model freight station also. These are all the things that we have to prepare and do along with the high-speed train project development. Thank you.
Okay, thank you so much, Than Rong Antipu, for giving us the good and relevant information about the high-speed railway projects of Thailand. And at the beginning, I forgot to tell everyone that based on the definitions of the high-speed rail definitions, we usually classify as the speed more than 220 kilometers per hour. I think most of Thai people cannot believe and cannot dream about that, right? Because now we are on the situation that we use the train running at the 90 kilometers per hour, and now we target for 250, that targeted speed that we looking for based on the Thailand constructions. And as far as I know, for the first phase of the constructions of the high-speed rail projects of Thailand, we rely on the Chinese technology. Of course, Thai government build all the infrastructure, but for the high-speed train, we're gonna use and bring in the China technology. The next panelist, Mr. Liu, gonna provide us the more confidence about the Chinese technology, about the high-speed rail cars. And I will let pass this one to Mr. Liu to present about the technology of the high-speed rail in China.
Good morning, ladies and gentlemen. My name is Liu Junyang from CRRTC Changchun. And I'm so great honor to share and exchange with you at such an international event. And my topic is innovation-driven and technology-leading. Products serve global users. In 2022, the 24th Winter Olympic Games and the Winter Paralympic Games were held in Beijing. At the most eye-catching transportation supporting facilities for the Winter Olympic Games, the Jinjiang Intelligent EMU connects the three major competition areas of Beijing, Yanqing, and Zhangjiakou. The Jinjiang Intelligent EMU has been developed since 2017. It's the latest achievement of China's high-speed train. During the Olympic Games, the Jinjiang Intelligent EMU has operated more than 1,600 times, transported 90,000 persons, and conducted more than 40 live broadcasts on the train. It has been highly prized by domestic and foreign passengers. As a train serving the Olympic Games, high efficient and punctuality are the most basic and important attributes. Between Beijing and Zhangjiakou is about 180 kilometers. It always takes us about 2.5 hours by car. However, it only takes 47 minutes by the Jinjiang Intelligent EMU, with 100% punctuality rate. So it not only brings the great convenience to the staff, audience, and athletes, but also greatly relieves the traffic pressure and becomes the first choice for low carbon travel during the Winter Olympics. Energy saving and environmental protection are the biggest highlights of the train. In order to reduce the air resistance, we designed a bionic head. The running resistance of the train has already reduced about 10%. In addition, we also use many energy-saving technologies, such as intelligent lighting, inverter air conditioner, traction control strategy, and lightweight design. The total energy saving is about 7%. The energy saving per year per train can meet the needs of 730 families for 1 year. The environmental friendly materials are widely used in the train. The internal and external noise has been reduced about 2%. The recovery rate of interior materials is about 75%. And the water conservation rate is about 10%. We interpret intelligence, green, and humanity from 1 drop of water, 1 dB, and a beam of light. The Jinjiang Intelligent EMU provides personalized and customized service for politicians, athletes, and reporters. The business area are set up in the head of the car. This area has completely independent riding space, providing private, comfortable, and intelligent services. And the first-class coach is equipped with zero-gravity seats, which can provide passengers and athletes with a comfort and a comfortable riding experience. We designed an accessible component on the train for the Winter Paralympic Games. The carriage is equipped with guide signs in Braille, wheelchair fixation area, accessible toilet, and hearing aids. As a customized configuration for the Winter Olympic Games, We set up many ski equipment storage cabinets and a doping test sample storage cabinet in the train. Sorry, there's no sound.
We open for you. While the train is moving. And I can also, without any delay, interact with a different person. Hi there.
Hi.
Who is actually in a different space. All of these technologies rely on 5G.
Okay, as you can see in the video, we built a live broadcast studio on the train operating a speed of 350 kilometers per hour. The train can provide intelligent catering service, and the passengers can order their food at the bar counter, the vending machine, or by scanning code on their seats. The train has realized 350 kilometers per hour automatic driving and beyond virtual range driving for the first time in the world. It is possible to identify the obstacles outside around the track outside 10 kilometers. As you can see in the video, we have established an intelligent operation and maintenance system to ensure the safe and healthy operation of the train. Connect the world with green and intelligence. Ignite passion with Olympic and culture. The Jingzhang Intelligent EMU has made passengers from all over the world feel the speed of China. Now, based on the Jingzhang Intelligent EMU, we have developed the second version products, including standard configuration and the Asian Games configuration. And all these trains are designed based on our mature, reliable intelligence and advanced Fuxing EMU platform. Of course, we also have product platforms such as passenger coach, subway, micro trains, intercity, and so on. Now, CRRC Changchun has used these products to serve users in 23 countries and regions around the world, providing assistance for their local economic development. In the future, with the development of human society, high-speed train is also facing demand challenges such as faster, safer, smarter, more environmental friendly, more energy efficient, more economical, more comfortable, and so on. So, what should we do to deal with these challenges? And our answer is people-oriented. It mainly includes three aspects: the needs of passenger, conductor, and maintenance. For the faster and more energy efficient needs, we can research aerodynamic, wheel-rail relationship, lightweight material application, and so on. For safer, deeply research the passive and active safety technologies. More environmental friendly, we can use new energy as our power system and use more environmental friendly materials. For smarter and more economical, We should provide services such as safety prediction, operation management, and intelligent maintenance, then improve operation safety and service quality. For more comfortable, continuously research technicals such as ergonomic design, active noise reduction, intelligent lighting, intelligent environmental control, and so on. Okay, innovation-driven and technology-leading products serve global users. CRRC Changchun will share the growth with value together with you and make human travel better. Thank you. Thanks for attention.
Wow. I think the audience in this room would amaze about the Chinese technology, because as far as we know, right, from Mr. Liu's slide, the normal speed of the high-speed train in China, 350. But for our targeted speed, it's just 250. It would be a piece of cake for the Chinese technology. And now, based on the Professor Jing presentation yesterday, now you're testing on more than 400 kilometers per hour already. I think we are, it just to me seems like we are in a different world now. But anyway, we just born, you know, in terms of the high-speed railway technology. And I think most of the Thai people, before the high-speed rail projects of Thailand established, everyone would know the Shinkansen, the Chinese high-speed rail technology. I think I heard about that for quite a long time, you know. But today, and as long as Tipu just said, we got the feasibility about the high-speed rail to Chiang Mai, and let the Japanese technology to have a look on that view on the construction of Thailand. I think for the next panelist, I will let the research fellow from Japan and lead us some background about the Shinkansen development and the current state of play of the high-speed railway technology in Japan. Okay, please.
Okay, thank you for having me today. I would like to introduce an organization that is a key player of Japan's high-speed rail development. We commonly refer to Japanese high-speed rail as Shinkansen, but today I'll use just high-speed rail for the sake of the simplicity. So let's begin with a quick overview of Japan's high-speed rail development. So the first high-speed rail lines opened in 1964, nearly 60 years ago, connecting Tokyo to Osaka. So over the decades, the operational high-speed rail line network has expanded over 2,830 kilometers, with an additional 623 kilometers currently under construction. In this graphic, blue lines represent operational high-speed rail line route, while the red and orange line represent under construction lines. This expansive network now connects major cities across Japan. The orange line, maglev Chuo high-speed rail, applies highly specialized technology, and it's a unique case. So its development is financed and managed by JR Central. That is one of Japan's railway operators. Except for maglev, all high-speed rail lines have been developed as public projects. And now, currently, the project scheme is determined by legally, and JRTT represents Japan Railway Construction, Transport and Technology Agency, plays a major role in the high-speed rail development. So in collaboration with various authorities, financial bodies, and railway operators, JRTT is a key player in high-speed rail development, overseeing construction and project management. So now let's talk about some general information of JRTT and explore its development in Japan high-speed rail development. This slide provides general information of JRTT. JRTT is an incorporated administrative agency of Japan. The same juridical status as some organizations like JICA or JETRO of Japan. Within Japan's expansive railway industry, JRTT stands as the only public agency for railway construction. Originally founded as JRCC in 1964, JRTT has a history over half a century dedicated to railway construction. JRTT's primary mission is construct new railway systems and provide financial and technological support to railway operators. These pictures showcase some of JRTT's diverse achievements. As you can see, JRTT has been involved in construction not only high-speed rail, but also urban railways, subways, monorails, and maglev, and undersea tunnels. In addition to these accomplishments, JRTT has also undertaken various technology development related to railway construction. They have received several awards from both domestic and international authorities. And this map displays all the railway lines constructed by JRTT over the years. There are more than 120 lines of various types of railways, with a total length exceeding 3,700 kilometers. In terms of recent accomplishment, in September of last year, the Kyushu high-speed rail from Nagasaki to Takeo Onsen was opened in the Kyushu region. Additionally, this March, the Sotets Tokyu Link line was opened to enhance connectivity between two private railway lines in capital region. So in railway construction, it is necessary to manage a variety of structures, including civil, track, station, depot, electric facilities, machinery, and more. JRTT maintains its expertise in these fields by employing railway-related engineers and years of technological inheritance. And throughout the railway construction, JRTT oversees the entire process, which includes EIA, public briefings, surveys, design, land acquisition, bidding, construction management, integrated testing, commissioning, and more. The successful execution of railway project requires not only technical expertise, but also effective communication with various stakeholders. And next, I'll talk about JRTT's role in high-speed rail development. These slides outline the legal framework for high-speed rail development in Japan. The one of key acts is the Nationwide Shinkansen Railway Development Act, established in 1970 for high-speed rail construction. The other one is Railway Business Act, established in 1986 for various aspects of railway business. This Nationwide Shinkansen Railway Development Act is specifically focused on high-speed rail construction, covering master plans, development programs, financial schemes, and appointment of construction entity and operation entity, implementation procedures, and more. So under this act, JRTT is commonly appointed as construction entity in high-speed rail project. On the other hand, the Railway Business Act encompasses types of railway businesses, addressing licensing, approvals, construction other than high-speed rail, fare regulation, inspection, safety measures, accident reporting, and more. For high-speed operation, this act applies to railway operators. And this slide shows a vertical separation scheme for high-speed rail. As the construction entities, JRTT acquires lands, constructs railway facilities, and retains its ownership. After opening the high-speed rail line, JRTT leases them to designated railway operators, like JR East or JR West. And as the operation entity, JR companies procure rolling stocks, operate and maintain the whole high-speed rail services. In return for the operation rights, they pay lease fees to JRTT, which contributes to the future project costs. And this slide outlines the financial scheme of high-speed rail development. These fees are determined by the operator's revenue difference between the scenario where the high-speed rail is developed and where the high-speed rail is not developed. And the graph provides a conceptual representation of how these fees are calculated. Once these fees contribute to the project financial resources, the government covers 2/3 of the remaining project cost, while local governments fund the remaining 1/3. And JRTT is responsible for executing these budgets for railway construction. And this slide provides an overview of related organization. From the planning phase to the opening, collaboration and coordination with various stakeholders are essential. So this includes legal procedures with the ministry, negotiations or collaboration with authorities and governments, funding, procurement, supervising contractors or suppliers, communication with local communities and railway operators. JRTT manages all these coordination efforts as the construction entity responsible for the implementation of high-speed rail project. This slide shows the current state of high-speed rail development in Japan. The yellow line represents operational line constructed by Japan National Railways, the predecessors of JR companies before their privatization, connecting Tokyo to Osaka and Hakata, and from Tokyo to Morioka. The blue lines represent operational high-speed rail line constructed by JRTT, or former JRCC. It's connecting to Hakata to Kagoshima, or to Nagasaki in Kyushu region, and from the capital region to Niigata or Kanazawa in Hokuriku region, and Morioka to Hakodate in Tohoku and Hokkaido region. And the red line indicates under construction lines managed by JRTT. The high-speed rail project requires substantial resources, including cost, time, human resource, and materials, so that the new network has gradually expanded, typically by 100 to 200 kilometers per project. So now I will introduce two ongoing projects, Hokuriku High-Speed Rail and Hokkaido High-Speed Rail managed by JRTT. This is the outlook of Hokuriku High-Speed Rail. This extension line was approved in 2012, and it's set to open in March 2024, just 6 months away. It spans about 120 kilometers, with 1/3 of the line comprised of tunnels, and the remaining 2/3 consisting of bridges or viaducts. The longest bridge on this route spans an impressive 558 meters across a significant river. There are 7 stations in this section, including Kanazawa, Fukui, Tsuruga, and more. And this picture shows the current state of this section as of July this year. As you can see, almost all the construction has been completed. Now, integrated testing has already commenced, and the test runs will be started by the end of this year, this month. And this is the outline of Hokkaido High-Speed Rail. This extension line was also approved in 2012 and is scheduled to open in 2031, approximately 8 years away. It covers about 210 kilometers, with a noteworthy 80% of this line comprised of tunnels, while the remaining 20% includes viaducts and more. Several major tunnels on this route spans over 10 kilometers, with the longest tunnel stretching for 33 kilometers. In Hokkaido, the weather condition is quite severe in every winter season. And there will be 6 stations in this section: Hakodate, Otaru, Sapporo, and more. And these pictures show the current state of this section as of July this year. Due to the unique geological conditions in Hokkaido, I think that excavation of work for several long tunnels will require some time. Okay, this is the end of my presentation. So as a key takeaway of today's presentation, please keep the name of the organization in mind, JRTT. Okay, thank you for your attention.
Okay, thank you so much, Mr. Yosuke, for leaning at the good way of practice, in terms of the construction through the Japanese experience. I come up with so many questions, but by the way, I'm gonna let the Q&A session at the end of the presentations. I think we would have around 20 minutes to exchange the idea. But to me, I got to come up with something about the establishment of the JRTT organization in Japan, who responsible all the construction projects of the HSR in Japan, right? When we think about Thailand at the moment, we are on the construction stage, but we would ask, who gonna responsible for that? But we have long way to develop for the Thailand story. But by the way, for the last panelist, Mr. Jürgen, actually we got a chance to have a chit chat, before the forums, before the sessions, and we come up with the good words about the fundamental type of thing about the high-speed railway, because we're looking for the higher speed, higher technology, and everything. But Mr. Jürgen will present us another perspective through the German experience in terms of the optimizations, another view of the high-speed rail considerations, and get back to the fundamental. What should we know? Of course, at the moment, everyone running away from the fundamental type of thing. Please get back to the fundamental about the high-speed railway through the German experience, please.
Thank you, Ajahn Pirapon. Yes, we are engineers in Germany. That's why I would like to point out in which direction high-speed rail should go into the future, especially under the challenges we are facing today. So the challenges we are facing, of course, is climate change, CO2 emissions, everybody know that, high energy prices, inflation, high government debt, migration into the cities, and the need for a climate-neutral mobility. This is my favorite picture for high-speed rail for two reasons. First of all, I'm from Cologne, this is my home city. I'm raised there while the first generations of ICE were rolled out in Germany. And the second reason is, while you can see old infrastructure like the Cologne Dome on the right side, 800 years old, and the main station of Cologne, 186 years old, actually completed at the same time with the Cologne Dome, in combination with the newest technology, with the third generation of ICE. Why is this so important? Because 80% of the investment for high-speed rail is for infrastructure and 20% for rolling stock and systems. So maximize life cycle preservation and maintenance is most important. And as you can see in Germany, we are preserving our buildings very well. In Cologne, we have sewer systems 1,800 years old. This is the best infrastructure in terms of efficiency, CO2 emissions, energy conservation you could have. And that must be the aim also for all infrastructure projects. At the same time, we need to maximize passenger throughput and utilization. That's why we call it intercity. We need to connect cities and countries. If we do not have enough passengers, the economic viability is not given. And maximize availability, safety, standardization, and automation. So you can see already these are all 4 generations of ICE we have in Germany. The first one in 1989 with 280 kilometer maximum speed, which stayed for the ICE2, also 280, and raised to 330 kilometer per hour in the year 2000. But now you can see ICE4, the Velaro, has a maximum speed of 250. Because we have different emphasis. We emphasize on energy consumption, efficiency, CO2 emissions, etc. I will elaborate this at a later stage. So my name is Jürgen Suppig, and I'm actually the treasurer of the GTRA of the Thai German Railway Organization, and I would like to encourage everyone to participate, be member. This encourage collaboration between Thai and German industries, Thai and German authorities, railway operators and government agencies. So it's a benefit for all sides for know-how transfer, workshops, etc. We have a webpage, gtra.in.th, where you can apply for membership. But I'm also CEO of Dorsch Consult Asia. We are a subsidiary of one of the biggest German infrastructure consultant, the Dorsch Group. We have many companies, specialized companies, for example, Dorsch Railway Engineering, German Railway Engineering, only specialized on railways. We have BLS, I mentioned that especially because high-speed rail also has a very important power component. Railways, high-speed railway trains consume up to 8 to 20 megawatt. That's the equivalent of whole medium cities of 20,000 employees. So you need to manage this very well. We have architect companies like Krebs and Kiefer, etc. And all together we are 7,200 staff members. We do 3,000 projects per year and have 70 years of experience. We cover all phases of infrastructure projects, from planning, feasibility, project development to implementation. I want to bring just a few examples with regard to high-speed rail projects we did. In the 90s, we did a feasibility study for the maglev Shanghai. You remember, actually, the technology was developed in Germany, and we helped to implement this in the very beginning. We did feasibility studies for interoperability of the major lines in Europe, which was very important. We do design and construction supervisions for several railway lines, but especially Hamburg-Berlin was important for us. 150 kilometer, 6.4 billion investment. But we also do high-speed rail stations design. For example, Berlin Central Station and Stuttgart 21. These are two major high-speed rail stations. And we do also projects abroad. Just an example, the high-speed line Beijing-Wuhan. This was done by our sister company. Thank you. I would like to point out a little bit the concept of high-speed rail. They're very loud because they're very quick. Normally we define them above 220 kilometer per hour because at that speed you need special technologies. You need special doors for pressure management. You need a special aerodynamic design, pressurized cabins, noise protection, ballastless tracks, welded rails, special curvature and cant, and sophisticated standard signaling communication systems like ETCS. A train, for example, with 300 kilometer per hour has an energy of a bomb of 450 kilogram TNT. And of 600 kilometer per hour, it's an energy of 2 tons of TNT. So this needs to be managed very well, you know, with systems, braking systems, maintenance systems, because it's a danger. But what many people do not know, they are not the champion in acceleration. They take time to accelerate. I want to bring an example. You have a train 300 kilometer per hour speed and a distance of 100 kilometer. So you can calculate easily, if you not consider acceleration, it would take 20 minutes for the train for this 100 kilometer. But as the acceleration takes between 6 and 10 minutes, actually in reality here you can see a real chart. This is between Cologne and Frankfurt. It takes even longer because in the city you cannot go full acceleration, you know. So if you accelerate 10 minutes, you just reach high speed of 300 kilometer per hour and you have to start the braking process already. So this is very clear. 100 kilometer are not suitable. So the normal distance between stations should be above 200, even 300 kilometer. One important item is energy consumption. Also, many people do not know that the drag force increases by the square of the speed. That means if you double the speed, you have 4 times the energy consumption. 4 times. Would anyone pay 4 times the ticket only to save 50% of time or maybe even 30% of time if you take the acceleration period out? Secondly, you see the density, the air density. On ground level, you have an air density which is 3 times more than on the travel height of, cruising height of normal airplanes. So you can see normal airplanes have 1/3 of the drag than high-speed rails. And this is the reason why increasing the speed, airplanes basically they compensate through the height. But on the ground level, you cannot compensate. The only way to compensate would be to evacuate more or less. I will describe this at a later stage. So this formula is the most important, which limits actually the speed, which makes sense for high-speed rail to 300 kilometer per hour, even less. Time savings, you can imagine, should be above 50%, you know, because if you do not have time savings, substantial time savings, the investment sum for the equipment and for the energy would not make sense. Another item is the curvature. For high-speed rail, you need a curvature or radii of 5 to 10 kilometer. Here you can see, this is just an example for Chiang Mai. You need a whole city in order to turn around the train, theoretically, but you can see On the right-hand side, left-hand side, there are mountains. So lots of villages, you need bridges and tunnels, which are very important and very expensive. But the aim should be, of course, to minimize the infrastructure as much as possible in order to have the highest return and the lowest environmental impact. In general, we have two different kinds of implementation concepts. We have separate dedicated alignments, as you have seen in the presentation before, which are completely separated from the railway network. And we have integrated alignments, which we have in Germany, Spain, Italy, for example, which are integrated into the existing network and can be utilized also by normal trains. This increases and maximizes the utilization of the network, of course. As I mentioned already, advanced train control safety systems are especially important for the safety, as you can imagine, with this high energy amount and distances of up to 10 kilometers only for braking, 10 minutes for braking. You need very efficient safety mechanisms, to detect obstacles, prevent potential collisions, and monitor the railways as well. You need to have an efficient schedule system, as more trains you can operate on the same line, as more energy efficient is your system, and you need to have the high reliability that you can utilize this infrastructure at all times. Standardization, normally it is interpreted with market protection, but it's actually the opposite. It should encourage competition. It should enable interoperability. We need to connect cities, because only cities have enough passengers which really could make these systems viable. And we need to connect countries. That's why it's so important that we introduce standards, because only if you have standards, these systems will be able to connect. And also, it will massively reduce the cost efficiency, increase the cost efficiency, because, of course, as more items can be produced, as higher the numbers are, as lower the prices will be in terms of production, as well as in terms of maintenance also. Innovation and upgrades. Innovation is also much easier if you have standardized systems, because you can really easy enhance it without start from the very bottom, from the very scratch. With regard to the implementation scheme, everybody talking of PPP now, because the governments are indebted and is huge investment required. But if you look on the list, these yellow highlighted items, they also should be governed by the government. Normally the risk distribution should be distributed to the party which can manage the risk best. And for all these items, the government is suitable. Especially for the investment, normally government guarantees are required. But of course, if the private party can cover it as a whole, it is admirable, but normally it is very difficult to achieve. For operation concessions, of course, they can be given to the private party. You can control key performance indices, you can limit the time of concession. This definitely makes sense, but there's a very high responsibility for the private party because the investment is so high. Other items like land acquisition, resettlement, and environment, statutory approvals, they are better handled by the government, as well as normally the ticket price, because this is a very highly political issue here, especially in Thailand. What about future technologies? In Germany, we have decided that maglev is probably not the suitable technology because of all the reasons I've mentioned before. It's just too expensive. You need huge copper resources. You need permanent magnets. You have very high and very resource intensive requirements, and it's not interoperable with the normal network. with Hyperloop, Elon Musk has, of course, immediately recognized that the drag force is the biggest problem, and he proposed evacuated tubes in order to eliminate the drag force. But this, of course, makes the evacuation nearly impossible. You sit in cabins which basically need to carry their own oxygen, which do not have windows. You know, actually in emergency, you need have an ejection seat like in the airplane. I don't think any one of the passenger would do that even. And then, in addition, the price would be at astronomical high. Also, in case of the tube, it's completely evacuated, only one millibar of pressure. So if this would implode, it would be a real disaster. That's why we believe in future the research and optimization for high-speed rail will shift from pure speed optimization to energy, CO2, and environment optimization, price optimization, safety, asset preservation, as I mentioned before, the best utilization, and of course the passenger comfort. So under the proposition of the challenges, which I have mentioned in the first slide, we believe the maximum speed will be around or below 300 km per hour in future. We believe it is absolutely necessary to minimize the infrastructure investment, to preserve the infrastructure and equipment, and to maximize the life cycle. This is very, very important. Station distances should be or must be above 200 km and below 800 km, otherwise the airlines would be more efficient. You should propose mixed and maximized utilization. As more you can utilize this expensive infrastructure, as more viable the project will be, environmentally and financial. And you always should use the highest level of technology, automation and standardization. Thank you.
Okay, thank you so much, Mr. Jürgen. Actually, the point that you just point out in the last slide, that hit me a lot, you know, but I'm not sure about the distance between station to station, about the Thailand construction, how much the distance. Now it seems 100 kilometers is not enough now. Okay, sorry for my laughing. Okay, I think we have around 15 minutes for the Q&A session, which I think would be the most important part of these sessions. I think at the beginning, I will let the ask for the questions from the floor. Anyone have the questions to ask the panelists, please?
My name is Dongkamon from Israel. Thank you for the interesting presentation. Just talking about the standard, as Mr. Itipu from DRT mentioned that we are going to have a Thailand Railway High-Speed Rail Standard. So with reference from China, Japan, and German, as Mr. Jürgen just mentioned about interoperability and standard. So maybe in case of, correct me if I'm wrong, in case of German, you need to connect to neighboring country, right? France or Belgium. So you need an international standard for build a high speed. And in case of Japan, it's Iceland. So there's no need to connect with the neighboring country. And in China, I'm not sure, you have your own standard or you have refer to the international standard. So when you hearing from that Thailand going to have our own standard, what is your suggestion? Could we refer to the international standard or could we have our own standard, something like that?
Okay, thank you for the question. I think this question is very important question because it seems we got the same mind. Probably the standard is very important. I think regarding to this question, I will start with the Rong Atipu first to address this question in the view of the regulator of the railway transport of Thailand.
Yes, thank you for the question. As I mentioned, we just set up for only 4 years. We just have about 30 railway standards, and we are in the process of developing more and more, including the high-speed train. High-speed train is the new technology, and we need to have the Thai standard, but related to the international standard. We don't want to set it higher than the international, of course, but we want to have the minimum that require the safety, or the safety, the technical that or the developer or the industry can enter to Thai market with a good standard and can compete to each other. And of course, because we need to connect it with the Lao PDR, connect with to the China in the future, maybe in the Malaysia. This standard have to be the one that can compatible with the others and also the international standard also. So my bottom line is our standard will be enough for the safety, but will be open for the all international for coming to Thai market.
Okay, thank you. I think the person who can address this, I think Jürgen, could you please address this question, because I think you know Thai environment and you know about the situation in Germany, about the international standard, because you got the border with so many countries, right? And what do you think about this, about the Thailand situation in terms of the standard? How can we set this up?
Yes, I think it's the right approach. You should not start from zero. There are a lot of standards available. You should select the right one which are suitable. But please do not forget to coordinate with your neighboring countries, that need to be integrated. And especially the European standard, I can tell you, they consider especially this, and I think from the Chinese we are not so far. There are also quite a lot of overlapping, so I can only encourage all, minimize the standard. It will benefit all of us, and go into the right direction, coordinate with all neighboring countries, and try to use the best examples you can have in the market.
Okay, thank you. And Yosuke, do you have some comment on this question based on the Japan perspective?
Actually, we don't have any cross-border connection regarding the railway lines, so I'm so interested in the connection from like Laos to China, and in the future China, Laos to Thailand. So we have to learn that situation for our experience.
Okay, thank you, Yosuke. And Mr. Liu, do you have some comment on the Chinese standard?
I think in my country we have we have just one standard for the high-speed trains, but in Thailand, I think we should consider the connect to the neighbor countries. So we will complete several standards and chose one which is sorry, how to say, can meet the needs different from different regions. So thank you.
Okay, thank you. As far as I know, I catch up from the panelists on the stage here. I think we got a big homework to do about the standard. As first, we have to serve our people, and at the same time, we have to think about the other country. I think the standard for the HSR for Thailand is a big homework for the authorities and the Thailand government. And thank you for these questions. And I want to, we're going to move to the, hopefully all the panelists address what you want to know, right, at this stage. And I would like to move for the next question. Anyone have the questions for the panelists?
Regarding the mixed traffics and dedicated tag for the high speed, there are two choices, right? Can you give more example on that? Because, for example, if Thailand gonna have a high-speed line for the first one. It will have a very low frequency of the train. It would be benefit if we can utilize that concept on the mixed operation, maybe in terms of the middle speed and high speed on the same line. Can you give some more information on that, please?
Yeah, this is a very good point, because of the huge distances between the stations, many regions will not be connected to high-speed rail. So you need to have regional railway in between to connect the small villages as well, and especially in the beginning, maybe you have 1-2 trains per day, so there's enough time to run regular trains on these tracks, The best would be, of course, to connect this even to the meter gauge railway network, and in long term transfer the meter gauge network into standard gauge, so you have a real connected network. But in Germany, we have lots of standard trains using the high-speed rail tracks as well. And then they can go on the normal tracks as well. And also the high-speed rail vehicles can also go on the normal tracks, but just with reduced speed. So this is a high advantage of flexibility. So it's very much encouraged. With this high investment, you really need to utilize your asset as much as possible.
Okay, it's very good point. It seems you got the. Okay, gonna be the last question for this session.
Thank you. My name is Warasara from Mahidol University. As someone mentioned the standards, and today we hear China, Japan, and Germany experience. I think one thing to take away is all the countries, you have your own high speed, like a standard, right? Just to make sure that in your country, it's interoperability, in your own country with different lines. Maybe come back to Thailand, since our country is more like a star, from northern, southern, eastern. I think it is very important, for Thai government to really think that, we make sure that southern, eastern, northern line need to be interoperable, and I think this is needed. Okay, and secondly, but we also hear and learn from Germany that, or even China, that the connectivity, between the border or neighbor country is really important. So I think that is also the lesson that, we can have our own standard at the same time, how we manage the interconnectivities. Because it's not just the train, right? To go through the border, it needs to be like, like a rule, regulations, license, drivers, something like that. So I just want to speak about that as an academic. Okay, thank you. But actually, I have a question for China. Actually, I'm really impressed of how China be able to, construct the high speed in very short time. I hear Japan, you have like RRTC. I would like to hear like China, like which organization and how you can manage to make it fast, so that we can learn from you, because I think for us it takes quite a while. Thank you.
Is that a hard question for you to answer?
Okay, I think that's a very good question. As we all know, the builds we Chinese have the quick, the very fast speed to build everything. So in my country, first the government will take a lot of the budget, all the companies will do something for the same goal. And I don't know how to say it, because I think the policy is very important, and the budget is very important. Okay, that's it. Thank you.
Okay, thank you, Mr. Liu, to address Ajahn M's concern and ask about how the high-speed train development in China is going very fast. Because I got a lot of Chinese friends. They just told me that the policy is very important. As you said, the strong directions of the government want to develop this is very strong. And then this is my personal opinion on this, Ajahn M, because I think the way that Chinese develop the high-speed rail, just one generation, to make more than a half of the high-speed railway network in the world. I think the policy is very important. And another thing is the budget. Of course, the government allocates a huge budget to development this. But I think the government, the Chinese government, set the goal very clear, the good path directions to go, and then they put the budget into that actions. That's why they can achieve that so fast. And the thing that I can see is the R&D is a big part of this development. I think the university faculties play a major role of this development as well. But I think this is going to be this my personal view, the Chinese direction is good for us, because without R&D, you cannot own your own technology. But now, if we're talking about the Thailand situation, if we're talking about the R&D, almost zero from now. I think we can imagine, right? How can we compare with China? It's impossible. And I think there's so many things to discuss about the high-speed railway in Thailand. Actually, I got my own questions about the Chinese got the CRCC, who responsible for the constructions and all standard of the constructions. The Japan, RRTC, got the responsible for this mission as well. But when we have a look back in Thailand, now we are under the construction stage. Who's going to be the responsible for that, This still got so many questions about the Thailand projects, but we have to keep this going. And one day, we dream for take a first trains of high-speed train in Thailand. Okay, it's time up now, and thank you everyone. And I would like to close this session. And before closing, I think I got another mission to give the teachers. Thank you. I would like to close this session now. Thank you everyone for participating. ขอบคุณครับ ขอบคุณครับ ขอบคุณมากครับ ขอบคุณครับ